that one though. That one though.
That's not right.
Yeah, I got it.
Finished this, but my Wi-Fi wasn't, or my Google Classroom isn't working for some reason. So, and you told me this is due before class today. Is that right?
The test review
Yes.
due before next class.
Oh.
Your test is not today.
But you said something was due a few days before the test, no?
I don't remember what you're referring to.
Did you want us to have this done today?
You're going to get a chance to ask questions about it, so yes, it's good that you have it done, because then you know what you need to ask about.
Okay, thank you.
I don't know what you're thinking of.
I don't know where I was at.
All right, guys. So we're a little bit behind a day, but we should be caught up by the end of the week, I guess.
So today we have set aside some time for our test review. So
Like we did with our first two tests, we need to give you a chance to ask about your test review, which is important. But even more important than your test review would be your quizzes.
So you either had those back or I passed those back to you at the start of class today.
So, just like your first two tests, you should expect your third test to look about 90% like your 4.7 quiz and your 4.8 quiz, stapled together, questions rearranged, different numbers, different angles, but same skills. So you shouldn't have any surprise there.
My A-Day class has already had to take it because there's been more A-Days. And
They did pretty well, but of course that's no guarantee for you guys. But with our test coming up on Thursday this week, at the bottom there, remind you about late work. If there's anything from this unit that you got a 0 on because you didn't turn it in,
or anything you got half credit on because you turned it in incomplete, you can still get half of those points back, but it has to be 100% completed and turned in before we start the test on Thursday. You can always turn those things in the Google Classroom. I get an email when you do that, when you turn it in late. And or you can turn in your hard copies before we start. So let me give you just a moment to start scanning your 4.7 quiz so you can see which questions you want to ask about. I know it's been close to 2 weeks since we've looked at 4.7, so I know you don't necessarily know exactly what questions you need to ask right away, but one thing to keep in mind is you should also glance at the questions you got correct. Just because you got them correct a couple weeks ago does not mean that you still remember what you did. So you need to look at the questions you got right and the questions you got wrong. Mirror maintenance.
So let me give you just about 2 minutes to start looking at your 4.7 quiz, and then I'll let you ask all the questions you want to from that. Then I will do the same thing with 4.8, the one you took last time I saw you. And then I'll take questions from your test review. I'd ask that you did at least half of it, so there's a good chance you have a few questions you know you need to ask. And then the rest of class you'll have to finish up the test review. The test review does need to be turned in. It is the last homework grade from this unit.
So as you finish that today in class, you should go ahead and turn it in Google Classroom so you don't forget about it.
Okay. So as we have done in the past, you guys know our quizzes, we have multiple forms. So question 3 is not necessarily the same question 3 as everybody else, so you do need to tell me which form of the quiz you have. But just focusing on 4.7 first, again, this is the section that is got the most information, so it's probably the one that you need to spend the most time reviewing. But it looks like we only use forms E and F for this quiz in this class. So, what questions would you like us to go over from your 4.7 quizzes? Jack?
2A.
Question 2A. Okay, which form do you have?
F.
F. Okay, question 2A for him is arc cotangent of negative square root of 3 over 3.
Oh, it's arctangent.
Oh, sorry. You said form F and I wrote down form F, but then I was looking at the other form. Arctangent of negative square root of 3 over 3. Okay, so this is asking you all inverse questions, arc questions and inverse questions, same thing. These are inputting a ratio and outputting an angle. I know my answer should be an angle, something like pi over 4, pi over 6, pi over 3, pi over 2, something like that. Of course, tangent values are always a little bit harder. So, what I would highly recommend at this point is memorize the values near the x-axis on the unit circle, r square root of 3 over 3, and tangents positive in 1 and 3, so these two are negative. Memorize that they are 1 or negative 1 in the middle of each quadrant, and square root of 3 not divided by 3 near the y-axis. Because short of doing that, short of memorizing those 3 values, near the x-axis divided by 3, near the y-axis not divided by 3, and the middle is 1. Short of that, you're going to have to do guess and check. You're going to have to take a point, pick an angle, do sine divided by cosine, hope that you get what you want, and if you don't, you've got to try something else. Guess and check, sine divided by cosine, sine divided by cosine, sine divided by cosine. But for us, if we have this memorized, it could be here or here. The one nice thing about tangent values is they're the exact same directly across. So now that I've labeled on my unit circle where I think tangent is those values, the second step is you should draw in the range of inverse tangent. You may notice on your quiz, and I do the same thing on the test, that sometimes if you missed a question, but I can see that you drew in the correct range and you know the range, I can give you some partial credit. But you've got to do it correctly to get those points. Like my 8A class, sometimes they would do this. That's not really the range. The range of inverse tangent doesn't include the endpoints. So if they included the endpoints, I could at least give them some partial credit. But this shows us the answer is here, which we usually call 11 pi over 6. But 11 pi over 6 is not within the range of inverse tangent. The whole point of memorizing these ranges is because your answer has to fall between those values. Negative pi over 6 is what you should have been aiming for. Yes?
So what was the rule about adding pi to
That's inverse cotangent if it's something negative and you're using a calculator. Yes.
Did you do 3A on Form F?
Form F again, number 3A. So of course, glance at 3A, make sure that you don't need help with that before you look at something else. I don't mind answering all the questions you guys have, but I'm not going to work the same question twice. So, okay, this one wants to know what angle has a sine of the sine at 4 pi over 3. So you might be tempted to say, well, these two are going to cancel and your answer is going to be 4 pi over 3. But there's no way that could happen. This is what we tried to get you to see with those true-false questions on the 4-7 worksheets. The range of inverse sine is negative pi over 2 to positive pi over 2, including the endpoints. So there's no way 4 pi over 3 could be your answer. But the fact that the inverse is on the outside tells me my final answer should be an angle. To work this one, we need to work this inside first. Now this is not an inverse function, so this is not unique to section 4.7 or 4.8. This is regular old unit circle. You have to go to where 4 pi over 3 is, and if you want sine, it's the y value. So the sine of 4 pi over 3 is negative square root of 3 over 2. But then it wants you to say what angle has a sine within the range of inverse sine that's negative square root of 3 over 2. So we go around the unit circle. Obviously this spot has a sine of negative square root of 3 over 2. That's where it came from. But then also this one. Remember, sine's the y values. So the point on the unit circle that has the same y value is going to have the same sine value. You should draw in the range of inverse sine so that you can see that your answer comes from here. And you would need to name that negative pi over 3. Is that enough?
Yes.
Okay, anybody else that was going to ask about this one have follow-up to it? Okay, then let's keep going. What else from 4.7? Yeah.
We do 2D on form F.
2B form F.
2D.
D is in dog
Yeah.
on form F.
Yeah.
Okay, that one was inverse cosecant of 2. So,
it says arc.
oh, I'm sorry. I wrote it down right. I just looked at the wrong spot. Arc cotangent of -1. Okay, so of all of these questions, arc cotangent are the ones that are the trickiest. But I can tell you, if you missed this, but you did well on the others on number 2, it's probably one little thing you need to consider. So this is not a draw a triangle question. Drawing a triangle never helps you get an angle anyway. So this has to be a unit circle question. When we memorize the unit circle, we memorize sine and cosine values. We certainly don't memorize cotangent values. But we can make this a little bit easier by changing this to arc tangent, as long as we do the reciprocal. But the reciprocal of -1 is still -1. And then again, if you don't want to do the guess and check, and there's no point in me doing guess and check up on the board because my guesses and your guesses would be different, you need to memorize in the middle of each quadrant, tangent is either 1 or -1, depending on if it's a quadrant that tangent's positive in or not. So that's enough to know that your answer is either here or here. And then here's where I think this question is almost too tricky. Almost. But it's still fair game. You guys like to look at this. You rewrote it this way to make it convenient to answer. And then you say, well, the range of inverse tangent is this, so my answer is right there at negative pi over 4. Negative pi over 4 has zero chance of being the correct answer because this is not an inverse tangent question. You're welcome to rewrite it as an inverse tangent question for convenience, but this is an inverse cotangent question. Your answer has to be in quadrants 1 or 2. That's not a problem with any of the other inverse questions. So your answer has to be in the range of the original question. So your answer is actually up here at 3 pi over 4. And again, I get why you change it to inverse tangent to help you find that location. I do the same thing. But your final answer has to match the question that's answered. If it's an inverse cotangent question, your final answer has to be in quadrants 1 or 2. Now, I guess if you want to make a connection to the Jack thing you were talking about with the calculator, in a if this was a calculator question, we would ask you, how would you type this in the calculator? And your best thing that you could do would be inverse tangent of the reciprocal, right? Your calculator is going to think you want an answer in quadrants 1 or 4, so it's going to give you this one, negative pi over 4. But then in your calculator, you had to add pi, because adding pi swings it around here to where you originally intended it to be. So it's the same thing we did with the calculator, but you don't have to know quite that deeply about what's going on. You just need to make sure that your final answer matches up to the range. In fact, when I look at these questions on number 2, I think a good idea would be, before you turned in this quiz, you should have made sure that on 2A, your answer was between negative pi over 2 and positive pi over 2. 2B, your answer should have been between negative pi over 2 and positive pi over 2. 2C, your answer should have been between 0 and pi. Because you know that's the whole point of those, memorizing those ranges. So if you're not applying them consistently, you can't expect your answers to always be right.
Just one sec. I gotta update attendance real quick. And grade book is slow. Okay. Okay.
What you got?
Well, whenever you get an answer of 0, let's say cosine of, this is hypothetical.
Okay.
Cosine of -1. No, just positive 1. And we get 0.
Cosine of positive 1?
Sorry.
I know what you mean, but this wouldn't be cosine. This would be
Sine.
inverse cosine.
Yeah.
If you're plugging in a ratio, it has to be an inverse. So sure, there's only one place where cosine is 1. The range of inverse cosine is 0 to pi.
So we just put 0.
So the answer to that would be 0.
Okay.
Yeah, I mean, that's as good a question as any of these on here. So, same skill. And what if it was inverse cosine of -1?
It would be pi, right?
It would be pi. It's just that, like, when we test you on these, part of the work we need to see is unit circle, and finding where cosine or sine is 0 or 1 are just, I don't know, kind of lame questions, but mathematically they're fine.
Okay.
That would be fair game. Okay, others from 4.7? What you got?
Form E, 2F.
Okay, this is the one that I was trying to do a second ago. This one, inverse cosecant of 2?
Yeah.
Okay, so same thing. When we memorize, this is not a draw triangle question. I realize that you guys can make a triangle with this. You could put cosecant is hypotenuse over opposite, but you have to understand inverse expressions like this are to give you an angle. Looking at this triangle doesn't help you understand how big this angle is. Sketching a triangle is great for almost half of these questions in this section, but it doesn't help you with a question like this. So if it's not, drawing a triangle doesn't help, then it has to be something from the unit circle. So when I memorize the unit circle, I don't memorize cosecant values, but I could do the reciprocal trig function as long as I do the reciprocal trig ratio. And now looking at this, sine is positive 1/2 in 2 places. The range of inverse sine is negative pi over 2 to positive pi over 2. Now if I take my advice from the last question you guys had, the inverse cotangent one, I shouldn't be using the range of inverse sine. I should be using the range of inverse cosecant. But inverse cosecant is almost the same thing. That's why it's not an issue. It's only inverse cotangent that's a problem. So your answer is right there. Should have been pi over 6. At pi over 6, sine is 1/2, so cosecant is 2. All right.
Form E2A.
E2A. Okay, so here's another one that's arc cotangent. So again, these to me have one little tiny more step that make them tricky. Most people change this to a arc tangent question by doing this reciprocal. And after you simplify that reciprocal, it comes out to be negative square root of 3. Then to find that location, you're going to have to do some guess and check, or better yet, memorize where tangent is negative square root of 3. But what makes this question one step trickier than this question, the range of inverse cosecant and the range of inverse sine are almost the same thing. They both use quadrants 1 and 4. So as long as you're not talking about 0, it doesn't really matter. But these two make a big difference, because if you continue looking at this, you're going to think your answer is here, but that's not the question. The question is what is inverse cotangent, so your answer has to be from here to here. So your answer is right there at 2 pi over 3. Okay, was that enough? Okay, others from 4-7 that are ready to go?
Can you explain number 7 on form E, which is a multiple choice question?
Okay, yep, and both forms had this. I think they're different choices or something though. But this is asking to make sure you understand how an inverse question is set up. So to compare this to a regular trig function, when we do a regular sine, cosine, tangent, the thing that we plug in is an angle. And what it equals is something like 1/2, square root of 3 over 2, square root of 2 over 2. All of those are ratios. And inverse just means you're swapping the input and the output. So now this should be the ratio, and what it equals should be an angle. So for your form E, that looks like that should be answer B. Now, I don't know if that I guess I should know if that question's on the test because I've graded 2 classes, but I don't know if this is on the test, honestly. I don't remember. But this is still good for you guys to know, because when I'm doing stuff like this, arc cotangent is supposed to equal an angle. If your answer is not an angle, there's no chance it's right. Arc cosecant. Inverse questions, the output's supposed to be an angle. If you have a ratio answer like 1/2 or square root of 3 over 2, that can't be correct. Your answer is supposed to be an angle. Inverse is supposed to equal an angle. Inverse is supposed to equal an angle. So that's what they're trying to get here. You're plugging in a ratio, but what it equals is an angle. Okay, let's move on to 4.8. And if I'm moving on from 4.7 too quickly, I will give you one more chance to ask about those. But for now, let's move on to 4.8. So 4.8 had you do some sides with SOHCAHTOA, some angles with SOHCAHTOA. There was the first time you saw some bearings, and had to use those alternate interior angles on one of the questions like we had talked about in the notes. But see what it is from 4.8 you'd like to get help on.
Could you do number 5 on form C?
Okay, and this question actually is the same on all the forms, which is good because I think it's one that you all need to ask about. This is probably the hardest question on this quiz, so I will do my best to reconstruct it. Okay, this question did have 2 bearings in it. They tell us this is 13 and this is 30, but you did not have to be able to read a bearing, I guess, to set the question up, because they put that in the picture for you. They also tell you this is 60 meters. So this has two parts to the question, but really there's one big thing that unlocks you getting the answer to both parts of number 5. This one's a bearing from C to A. So if someone was standing at point C, you need to give them a bearing that sends them towards A. So most people started off at a north line. That would be right here. And then they want to turn to the left, which would be towards the west. And how much you have to turn is 30 plus this whole thing. So that tells me, before I can answer this question, I know it's going to be 30 plus this, but I'm going to have to figure out what this angle is in this triangle. So I can't really give an answer to part A yet. Then part B wants us to find this length from A to B. I'll label that as X. And I can't do Pythagorean theorem because I don't know two sides. But if I had this angle, the same highlighted angle, I could say the tangent of that angle, I'll come back and replace it once I know it, is equal to opposite over hypotenuse. So the answer to the second part of this question is 60 times the tangent of angle C. But to answer both of these, you have to figure out this angle C. So that takes a minute to even figure out. That's important, and that you need to do that. Now, you can spend several minutes here trying to figure out how to come about finding out angle C. You don't have two angles of a triangle to subtract from 180. You don't have two sides of a right triangle to do inverse SOHCAHTOA. At some points, you have to admit that you don't know enough about the angles and you need something else. So, the only way to get more angles on this question was what I tried to warn you about in the notes. This is a north line. This is a north line. So those two lines have to be parallel. This is a line that intersects those two lines. So this could be your transversal. And I don't care what type of angle relationships you want to use from geometry, but just for consistency, I stick to alternate interior. Interior means that it's talking about the angles inside the two lines. And the alternate means they need to alternate. Top left alternates with bottom right. Bottom left alternates with top right. I'm going to use that first one that I said, because how big is this angle? One more time. Okay, so 103. And that's in the top left of the interior. So he's going to alternate with the bottom right in the interior. This is 103, this is 103. So if you did that connection, then you should be just about finished, because these three angles make up half of a circle. You know, this much of it's 30, this much of it's 103, which means this whole thing has to be 77. Now I can finish my answer for part A. From the north line, we turn 77 degrees towards the west line. And now that I know that this part of the angle is 47, oh wait.
Isn't it 47?
This is supposed to be 47. Sorry. I'm cheating a little bit because I know the answer, so I wasn't doing the arithmetic in my head. So if this whole thing is 77 and this much of it's 30, then this much would be 47, and that was the last thing that you needed to get your answer. So 60 times the tangent of 47 came out to be about 64.342 meters. Okay, what questions do y'all have about that number 5? You could, but for it to be a transversal, you're going to have to think about this north line going up further, and then this could be your transversal. That could also be a transversal. The problem is, with that as a transversal, I don't know how big this interior angle is or this interior angle is, and so that's not going to help me get more information down here. So even though it's true, since I don't know those angles, they're not real helpful. Jack, you had something else about this?
Yes, sir. So, I don't know. I got the answer right, but I don't know, like, how. So, I took the triangle, and I, like, flipped it just a little.
Wait, you don't know how you did it?
What?
You don't know how you did it, and you expect me to know how you did it?
Well, just, I want to see if this would work every time.
Okay.
Understanding his reasoning. So, I took the triangle, and I flipped it onto an x-axis. So I made the north be the y-axis, and I just created an x-axis. And then I moved the triangle 13 degrees to the left. Yeah,
Like,
and then
okay.
it would be 43 degrees. That's how I got the bottom right corner angle to be 47. Will that work every
Okay,
time?
wait. I think what you're saying is probably fine, but there's a couple things you skipped over there, or I didn't catch. Okay, so you drew in a line here.
Yeah.
Okay, fine. What did you go from there, though?
In my head, I brought the triangle down.
You
Like-
brought the triangle down.
Yeah, like I rotated it 13 degrees to the left to make it even with the x-axis.
Okay, so you're tilting this back this way. Okay.
And then, so the right side would be 43 degrees to the left. Or like 43 degrees pointing inward.
I'm not comfortable saying that's always the case. By pulling this 13 degrees this way, would that add 13 to this every time? It might, but I'm not comfortable saying that works all the time. But I thought you were going to say something else, which would have worked. So this is something different. So maybe this would be safer. You know this is 103, right?
Yeah.
Okay, well with your line that you drew, couldn't you find this angle right here now?
Yeah, make it, yeah, that one.
77. And then if you didn't realize that this angle and this angle were alternate interior, to know this whole thing was 77, so this part was 47, you could say, well, this makes a right angle, right? North line and a east line make right angle. So that makes this little sliver how much?
23.
Or 13.
No.
And then if you know these three have to make a right angle, if this is 13 and this is 30, then this has to be 47. So that, I feel comfortable with that, but I'm not sure about your rotating, if that's going to be consistent all the time. Okay, these are good questions, but is there anything else about 5? Okay, what else from 4.8? Okay, then I promised to give one more chance for 4.7 if I had moved on too quickly. Was there anything else from 4.7 you didn't get a chance to ask?
Can you explain number 9 on Form E?
Number 9, Form E. Explain why arc sine of 1.3 is not possible. That one?
Yes, sir.
Okay, so in this question, this input and the values that you input, the values that you can input, in mathematics we call that domain. So going back to question 1 in that chart, what is the domain of inverse sine? It's the same as the range as regular sine. So So what sine look like? What was the range of sine?
-1 to +1.
Okay. So if the domain is -1 to 1, domain's not something that we just like to ask to see if you can do it. Domain is important in mathematics because it's a way to describe what numbers make sense. It does not make sense to plug in a number bigger than 1 here because there's no angles that have a sine of 1.3. So the quickest way is to say, because it's not in the domain, which is -1 to 1, I also accepted, some people were kind of wordy, but sine is, this is sine. Sine is opposite over hypotenuse. Hypotenuse is always the biggest side, right? So this fraction could never be bigger than 1. If your denominator is bigger, then your fraction has to be less than 1.
Say that again, sorry.
Your hypotenuse is the biggest side. Anytime in a fraction when the denominator is bigger than the numerator, that value is less than 1.
Okay.
So for it to be 1.3, the opposite would have to be bigger than the hypotenuse, which doesn't make sense.
Gotcha.
So that was fine too. But the quickest way is to refer to domain. That's what we're really interested in. Okay, is there something else from 4.7? Okay, then again, those are by far the most important resource.
But second most important would be the test review. So I gave that to you after you guys took your quiz last time.
Ask you to do at least half of it between then and now. Partly so that you would have some idea of the questions you need to ask, and partly so that you could finish up this test review and make sure you got all your questions answered before you left. So, you guys are welcome to ask questions as you get to them, as you work on the test review, but if you have any questions from this ready to go, then there's no point in waiting. So, anything you've looked at or tried on the test review that you'd like me to go over with you.
Can you go over again how to do those, like when you plug in the values of the calculator and figure out how to do it? It's on 23. There's a bunch of those questions.
Okay, if it is inverse sine, inverse cosine, or inverse tangent, your calculator has those programmed in. So you can just type this one in as inverse tangent of 6. Now your calculator does have to be in radian mode. From a mathematical standpoint, inverse trig functions only exist in radians. So I can just type that one in. The answer it gives me is the answer it gives me. I could do that with inverse sine. I could just type that in exactly the way it looks. What it gives me is what it gives me. You're going to be tempted to do this one, but before I even type this in my calculator, I know something's wrong with this. The domain of inverse cosine is -1 to 1. I can't plug in a number less than -1. So you can type that in your calculator if you want to, but it's going to say error domain. So this one is not possible. Not that my calculator is limited. It's just that there is no angle that has a cosine of -4. So inverse sine, inverse cosine, inverse tangent. You can just plug those in as they look, as long as the number is a number that makes sense.
So all these values are domain values?
The input is the domain.
Okay.
Now, if you want inverse secant or inverse cosecant, your calculator does not have a button for those. So the best that you can do is to do their reciprocal trig function, but then you have to do the reciprocal ratio. So this is what you'd have to type in for this one. But then what it gives you, you can trust it. This one, the closest you could do is inverse sine. But again, it's got to be the reciprocal ratio, and the ratio is now the input. But what it gives you is what it gives you. The only one, and you might want to go back to that handout, but the only one that's extra tricky is this one. the closest I can ask my calculator to inverse cotangent is to do inverse tangent of the reciprocal. The problem with this is when I type this in my calculator, it thinks I want an answer in quadrants 1 or 4 because that's where inverse tangent exists. I want an answer in quadrant 1 or 2 because that's where inverse cotangent exists. So I have to type this in my calculator. And the answer that is given to me would probably be listed as a multiple choice question. But that is not the answer. This is a negative angle, a negative radian. It's given me a spot real close to 0 about right here. So the spot directly across the circle is going to have the same tangent value, and if it has the same tangent value, it has the same cotangent value, and the way you go halfway around the circle is you have to add pi to that.
And what's the general rule on that? Is it anytime there's an inverse cotangent value that's negative, or?
Yes, you only have to do that on inverse cotangent of something negative.
Negative, got it.
Inverse sine, inverse cosine, inverse tangent have all been programmed to work. Inverse secant and cosecant don't have an issue because cosine's range is this, 0 to pi, and secant is the same thing, it's just that he's undefined as that, but it uses the same quadrant, so it's consistent. The same with sine and secant. Sine's range is this, and inverse cosecant's range is this, but they both care about quadrants 1 or 4, so it's not problematic. The problem one is inverse tangent versus cotangent. Inverse tangent is here versus inverse cotangent is here. They're different. So if it's something positive, they both exist in quadrant 1 and it's not a problem. But if it's inverse cotangent of something negative, the way you type it in your calculator is going to give you an answer down here. You've got to add pi to get it to swing around to where you need it to be. So only inverse cotangent of something negative do you have to add pi. And again, it's not a problem of the calculator or anything, it's just a limitation of how we have to enter it in. So okay, any other test review questions that you know you want help on? Okay, then let's see what we got here. We got about 45 minutes. So again, I know most of you are probably not done with the test review because I didn't tell you you had to be finished with it, but you do need to finish it in class so that you get your questions answered. So I will set a 15-minute timer. So go ahead and pick up wherever you have left off and check your answers as you go along. And in 15 minutes, I'll let you ask to see some more worked out. And then we'll do that a couple times till we run out of questions or we run out of class time. You checked all your answers already?
I think so. I'll go check the key now.
You might check them real quick just to make sure.
Yeah, sure.
I'll be bugging you for questions in about 6 minutes. been 15 minutes. So, is there anything you've found from the test review that I can help with? Yes.
On number 9,
Mm-hmm.
would it be 5 over 6? Because,
Yes, 5%. Because it's the same location where tangent is the reciprocal, which happens here and here, but since it's an inverse cotangent question, you need to pick that one, 5 pi over 6. That's correct. Okay, others from test review? Okay, I'm gonna give you another 15 minutes then before I bug you again. Of course, make sure you're checking your answers as you guys go along, just in case you think you got something down and you actually are missing them. And those of you that are finished or almost finished, remember you will need to turn this into Google Classroom, so if you're done, you might as well go ahead and do that so you don't run the risk of forgetting about it. But I will ask for more questions in 15 minutes.
Bless you.
Alright, it's been almost another 15 minutes, so we've got 15 minutes of class left, so this is really your last chance. Anything else from the test review that I can help on? Alright, so again, just since this test to impact your grade quite a bit more, say all the important stuff one more time. Make sure you feel comfortable with both your 4.7 and 4.8 quizzes first. Then make sure you're comfortable with the test review. Make sure you have the test review turned into Google Classroom. Any late or incomplete work from this unit, if you want any more points from those, you need to do that before the test. So add that to your homework list. And of course, you should put some sort of a reminder somewhere about your test on Thursday. Even if you don't think you need to study much, 5 or 10 minutes is still a lot better than 0. So. Alright, but you guys do have about 15 minutes of class left, so I guess if you do find something, you're welcome to bring it up here and ask. Otherwise, I guess that's all I've got.